Conversion of binary numbers to octal numbers to hexadecimal numbers and vice versa. Binary numbers is a base 2 number system with the valid digits 0 and 1. Octal numbers is a base 8 number system with the valid digits from 0 to 7. Hexadecimal numbers is a base 16 number system with the valid digits from 0 to 9 and A to F. Let's start converting binary number to octal number. In the given 111010 binary number, we're going to convert it into octal number. Let's divide the binary number into two parts and write it separately. Using the by power method, we're going to multiply it by the power of 2, which are 1, 2, and 4. On the first part, which is the right part, let's multiply 0 times 1 is 0, and 1 times 2 is 2, and 0 times 4 is 0. On the left part, 1 times 1 is 1, 1 times 2 is 2, and 1 times 4 is 4. With these products, on the left part, let's add 4 plus 2 plus 1, and we get the answer 7. Since on the right part, we only have two numbers, let's combine it with the 7 to have 7 and 2, which is 72, and the octal number of the given 111010 binary number is 72. Note that we cannot convert octal number direct to hexadecimal number. We need to convert first octal numbers to decimal numbers, and from decimal numbers, we can now convert it to hexadecimal number. Let's now convert octal number 72 to decimal number. Using again the by power method, let's multiply 7 and 2 by the powers of 8. 8 raised to 0 is 1, so 2 times 1 is 2. And 8 raised to 1 is 8, so 7 times 8 is 56. Let's add the product 2 and 56 to get 58, which is the decimal number of the octal number 72. From the decimal number 58, we can now convert it to hexadecimal number. Using the division quotient remainder method, we're going to convert decimal to hexadecimal. Let's divide the decimal 58 to 16. We use 16 because we are converting it to hexadecimal number. And the hexadecimal number is a base 16 number system. We're going to divide 58 by 16, and we get 3.625 as the quotient. Let's get 0.625 and multiply it by 16 to get the remainder. And the answer is 10. And in hexadecimal number, numbers 10 to 15 is converted as letters, which are A, B, C, D, and E, and F. So number 10 in hexadecimal number is equivalent to A. Now let's get the integer quotient 3 and divide it again by 16. 3 divided by 16 is equals to 0.1875. Let's get the 0.1875 and multiply it by 16, and the answer is 3. Let's write the remainder from bottom to top to get the hexadecimal value, which is 3A. Let's list down all the numbers that we converted from binary to octal into hexadecimal. The binary number 111010 is 72 in octal number. And the 72 octal number is 3A in hexadecimal number. Now, let's do the vice versa, hexadecimal to octal and to binary conversion. Hexadecimal to decimal. Note again that we cannot convert hexadecimal number direct to octal numbers. We need to convert first hexadecimal numbers to decimal numbers, and from decimal numbers, we can now convert it to octal number. The hexadecimal 3A is going to convert to decimal number. Using the by power method, let's multiply the 3 and A by the powers of 16. 16 raised to 0 is 1. So 10 times 1 is 10. And 16 raised to 1 is 16. And 3 times 16 is 48. Let's add 10 and 48 and we get 58 as the decimal number. So the decimal value of hexa 3A is 58. Let's now convert decimal to octal. The decimal 58 were now converted to octal number. Using the division quotient remainder method, let's divide 58 by 8. We use 8 as the divisor because octal number is a base 8 number system. 58 divided by 8 is 7.25. Let's get the 0.25 and multiply it by 8 to get the remainder 2. And let's get the integer quotient 7 and divide it again by 8. 7 divided by 8 is 0.875. 0.875 will multiply by 8 and product is 7. Let's write the remainder from bottom to top to get the 72 as the octal number. So the decimal 58 is 72 in octal number. Now, from octal number, let's convert it to binary numbers. The octal number 72, we're going to convert it into binary. Using the by power method, we're going to find 7 and 2 in the powers of 2. Let's first focus on the 7 on the left part. Let's find number 7 in 4, 2, and 1. If we add these 3, we're going to get 7. So it means 4 plus 2 plus 1 equals 7. And 7 is equivalent by the octal digit 7. So it means that we use the 3 powers of 2. So the equivalent of this number is 1, 1, 1. And on the right part, 1, 2, and 4, the only number that we can use to have 2 as a sum is number 2. And if binary number, we're going to write it as 0, 1, 0. Why 0, 1, 0? Because we didn't use 1 and 4, so it will equivalent to 0. And the only number that we use is 2, so that is only equivalent to 1. So the binary number of octal number 72 is 111, 010. Let's now list all the converted numbers from hexadecimal to octal and to binary. The hexadecimal 3A is converted as 72 on octal number. From octal number 72 is converted as 111010 in binary number. Now try to convert the given binary number below to octal and hexadecimal number and also vice versa.